Section 3.4 Part B, so that we're still in general annuities, but now we're doing interest less frequent than the payment. So that means our exponents, our EIR exponent is a fraction, okay? Because again, we're still doing compound interest. So compound interest for part of a period means that we have the effective interest rate. So again, just to review, we have our giant timeline over here. We have AN deferred. Here's A sub n, many periods later. Next, we have our regular payments. Here would be AN due. Then our next regular payment. And this is, however far they are apart. We'd want to note that on our timeline. Here's our last R. And then at the time of the last payment, that's S sub n. One payment period later is SN due. Okay. And then many periods later would be SN foreborn. Okay. So today, we're going to be using our main equation is going to be, again, EIR, which your book calls I sub x, 1 plus your current I to the y minus 1. So remember, I is R over N, okay? R over N, or in our case, we're using old and new, so it's R over your old, okay? And then Y is old over new, so whatever we're converting it to. So old is what we're currently having, and then new is what we're trying to convert it to, okay? So just jumping back to our timeline here, remember we have N regular payments, and then moving forward, that's our M, and then here is our P, okay? AN deferred to AN is the P for counting. So now we're going to go ahead and move on to example 3A. Okay, so we're doing, 30A. 30A. So here we have, we want to find the monthly interest rate. So that means that our new is 12. And we have an R of 6.1%. So 0.061 is R. And right now that's compounded quarterly. So that's our old. Okay, quarterly is 4 times a year, so that means our exponent, which was old over new, is 4 over 12. You can leave it as that, or you could reduce it. It reduces to 1 over 3. So then our effective interest rate is going to be 1 plus 0.061 over 4, because that's our old, to the 1/3 power minus 1. On our calculator, that looks just a little funny, but it's not too bad. So that's going to be 1 plus 0.061 over 4. And then and then we need another set of parentheses because we have a fraction exponent to the 1/3 minus 1. Okay, so we get 0.0051 when we round. 0.51% would be our effective interest rate if we're not using it further and we're just finding the effective interest rate. Now remember, when we do this in a problem, we have to save that as A. So we're going to skip 31 and jump straight to 32. So on number 32, you guys can do 31 on your own and check your answer. That one's a little easier to set up. This one is a more difficult exponent, so I want to do this one together. Okay, so beginning on April 1st, 2004. So we are 4104. 15 quarterly payments. It tells us N is 15 automatically. Quarterly tells us that our new is 4 because we're compounded annually, so that our old is 1. Okay, old is 1. And our rate is 0.058. So that tells us that our current I 0.058 over 1, and that our exponent is going to be 1/4. So the EIR is going to be 1 plus 0.058 over 1 to the 1/4 minus 1. And let's do that quick on the calculator. So we get 0.014. But it keeps repeating, so again, we're going to store that as A. Okay, so that's stored as A. And then, so on our timeline, we're trying to figure out the size of the payment. So that means we're trying to find R. It's quarterly, so our next payment would be 7104. We want to show when the next payment would be to help us understand that we know what's going on. Okay. And then we have 15 payments, and then we want to know how much do the payments have to be so that we have $25,000 on July 1st, 2019. Okay, and then we're assuming compound interest is paid for part of a period, so that's how we know to use EIR. Okay, so when we work on this, we already know N, but we have to figure out when this last day is, because we have to figure out how much this is, and this is our M, how many periods this is. So we have to figure out when this is. Okay, so I'm just gonna make a quick table. So I'm gonna bump over here, make a quick table. So we have January, April, July, and October, and we're starting in 04. This was our first payment. Remember, we have okay, so that means that our 15th payment would be October 07. So this is going to be 10/1/07. And then now we have to keep counting. So now we're counting M. So we have to go all the way to 2019. Okay, 2019. So instead of doing a table, because this one's going to be really big, it's over 10 years, I'm just going to write it out. So here we have 4 payments a year. We're doing 2008. We're going to include both components, and we're going to have the full year in 2018, 3 in 2019, so we should get 47. Okay, we have 3 in 2019 because we have the January, April, and the July one. Okay, 2 would only count January and April, but we still have to make it to the July, so that's why we have 3 there instead. And here again, we're adding 1 because we're including both endpoints. Okay, so now that we have M, it's 47, we know N, we're ready. So with this one, because it's so big and it's at the end, we know it's S15 for born, and that's going to be equal to our $25,000. So we have 25,000 equal to R times 1 plus A to the 15 minus 1 over A times 1 plus A to the 47. Okay, so again, this is 15 is our N, 47 is our M. So we have to figure out what this big coefficient is. So we have 25,000 is equal to R times some really big number. So we got to jump back to our calculator to figure out what that is. So we have a set of parentheses, then another set of parentheses, and then we have our 1 plus A, and that's to the 15 minus 1. That's our numerator, and we're dividing that by our denominator, which is just A. You don't need parentheses there, but I think it's helpful. And then we're going to multiply that by 1 plus A again. And then we're raising that to the 47. So this is our coefficient, 32.17. And it keeps going, and again, we're not going to divide by that, so we're not going to round that, so we're going to get R is 25,000 divided by whatever that answer is in our calculator. And remember to use that, you do second answer. So our regular payment, we see is 777.118, and we round up. So we get this value as our regularly scheduled payment.